Hello everyone, welcome back. So this time we're going through example 2, and we see we have a system of forces. Here we have 3 cables that are supporting this plate, and we have one force pressing down on this plate. And we want to figure out what the tension in each of the supporting cables is. Okay, so how are we going to do that? Well, as you probably guessed, we're going to set up a free body diagram. We're going to write the forces using our scalar equations, and then we're going to just solve them. It won't honestly be that hard. That's another fun note. If you look at this, you notice that we have a system of parallel forces, which means we should be able to reduce this to a single force. We're trying to find out something that has equivalent force. But I guess this is support, so it doesn't really work here. I'm always excited when I see things that are parallel. Also, in parallel systems, things are much simpler. So first off, free body diagram. It's pretty simple. We just cut the lines, and we make sure that we add in the weight of the plate. Cut the lines, add in the weight of the plate. Okay, so we have this free body diagram here. 3 unknowns, and we get 6 scalar equations. This should be a cinch. So first off, some of the forces in the z direction. We have all 3 of these, and our 2 forces right here. And then we've got to think to ourselves, well, how are we going to get rid of some of these unknowns? Well, if I think about it, I think about it pretty hard. I can probably find a way to simplify this greatly. In fact, I can probably simplify this a lot more than they did if I wanted to. But we'll leave that for now. So, with that in mind, let's look at it. So what did they do? They did some of the forces in the z direction, TA, TB, C, and these 2. Some of the moments around in the x direction, around our origin it looks like. And that would be TA times 3, which is 3 feet. And then we have TC times 3, okay. And then we have 500 times 1.5, and 200 times 3. Okay, so all these forces, we got 2 unknowns here. And then we have some of the moments around the y-axis, which is TB and TC, okay? So there is no moment around the y-axis because of A, because it's on the y-axis. And so we have TB and TC both causing a moment. And we see that they are both 4 feet away. As a note, this will mean that they're equal, just different numbers. Or maybe one's negative, one's positive. And then we have our weight here and our force applied here. 3 equations we can solve. So we plug it in there, we do some math, and eventually we can solve for it. I was completely off on this, which is what happens when you guess. Sorry, that did not mean that those were equal. This is why you don't do algebra in your head. Okay, I see that TC is 100 pounds, TA is 350 pounds, and TA is 250 pounds. Now, let's try something a little bit different here. Okay, so everybody remember that this is 100, 350, and 250 right here. And we actually have a little typo here, so that should be TB, I believe. Let me look at this. Yes, TB should be 250 pounds. Okay, so let's come back to this one right here. I'm going to get rid of this. So TB is 250 pounds. Now here's the reason that you should always look for a more simple way to solve this problem. Because you just had to solve 3 sets of simultaneous equations. That's not fun. And that's because I took my moment around the origin, right over here. That wasn't smart. I should have taken my moments around this point right here. And you're wondering why. Well, let's take the sum of the moments around the x-axis at point C. So sum of the moments around the x-axis is at point C. There is no moment at point C, so we don't have to worry about this. I'll make sure I put a little C right here. C. Well, what forces cause a moment around the x-axis? This one doesn't. That one doesn't. That one doesn't. Do you see where I'm going here? And so what we get is TB times 3 minus 500 times 1.5 And guess what that means? Therefore, I'm sorry, that should be equal to 0. And you can solve this pretty simply. Which means that TB will be, guess what? 250 pounds. Okay, so you're like, okay, well that one is easy, but you still got 2 more unknowns. Probably not going to be simple now. Just watch. So I'm going to pick that same exact point, and now I'm going to take the moments around the y-axis at point C. Once again, this is why those equations are amazing. I always do some of the moments first. So some of the moments around the y-axis, this is still at point C. So I know TB now. This is 250. I solved that for my first equation. If I'm doing around the y-axis, it doesn't actually count. It doesn't do anything for that moment. However, this one does, and this one does. But as you can see here, I only have one unknown. So it's going to be equal to 0, which is equal to, I'm going to do TA times 4 plus, minus 500 times 2 minus 200 times 2. It's all equal to 0. Now if I solve that, I see I got 1,000 here, 1,400. Okay, so that'll be 1,400 okay, that's all equal to 0. And I divide 1,400 by 4, and I get that TA is equal to 350 pounds. Okay, now if you're wondering, well, can we do some of the moments around Z and solve for anything? That doesn't actually do anything for us. If I wanted to, if I really wanted to solve for TC, I could go over here if I wanted to take moments. But at this point, it's probably just easiest to use my sum of the forces in the Z direction. And since I already know everything, and you're done. I didn't have to do any algebra. I hate doing algebra. And so honestly, you should always think about these problems and try to avoid the algebra if you can. Choosing what point you take your moment around will many, many times save you a whole lot of work, as this problem hopefully showed you. So, that being said, I hope you like this. Hope you realize the importance of keeping it simple. And I'll see you all next time. Bye-bye.